All right, I'm picking up on chapter 10, section 1. This is part 2. I messed up on letter E on my other video, so I had to end up going back and deleting it. So anyway, we'll start right here at letter E. So we still want x by itself. If you have something that's not inside the parentheses, you can go ahead and move that to the other side. So the first thing we're going to do on this problem is subtract 10 from both sides. So then we're done with that. So we bring down our x plus 7 squared is equal to 8 minus 10 is negative 2. So then how do we get rid of the squared? We find the square root. So then we end up with x plus 7 is equal to, and then look what's going on right there. Remember we talked about you cannot have the square root of a negative number because then it's a non-real number. So if you ever get to a position where you have the square root of a negative number, you can stop and you can say that there's no real solutions. You'll get into imaginary numbers in college algebra, but in this class, if you get to a problem like this, you can stop and automatically say no real numbers. All right, we're moving on to a theorem I'm sure you remember from high school, at least the name, the Pythagorean theorem. The Pythagorean theorem deals with right triangles, which is just simply a triangle with one 90-degree angle. A theorem is a statement that has been proven to be true. And so it says, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the two legs. Now, what in the world does that mean? Well, all right triangles have two legs, so the two sides that meet and create the right angle are called the legs. And then the side that is across from the right angle, which is always the longest side, is the hypotenuse. So that's what a hypotenuse is. It's the longest side of a right triangle. And mathematicians have proved that for any right triangle, if you take the two side lengths, let's say we have one that's 3 centimeters, one leg that's 4 centimeters, and a hypotenuse is 5 centimeters. Okay, and if you take those two legs and you square them, so 3 squared plus 4 squared, in right triangles, those two numbers squared and added together is always going to equal the hypotenuse squared. For example, 3 squared is 9, 4 squared is 16, and what does 9 plus 16 equal? Well, it equals 25, which is 5 squared. That is a true statement. And not just those numbers, but any numbers that work in this formula, that means that if you put those side lengths together, it will always, always, always form a right triangle. Okay? So how does that apply to this unit? Well, let's find out. It says, if a hypotenuse of a right triangle is 15 centimeters long and one leg is 10 centimeters long, what is the length of the other leg? With the Pythagorean theorem is always in the statement a squared plus b squared equals c squared. A and b are the two legs of a right triangle. Doesn't matter in what order you have those two legs. But C is always the longest side, and that longest side is always called the hypotenuse, which is across from the right angle. All right, so if you draw a right triangle, that didn't match up, but it didn't matter. That longest side across from the right angle is the hypotenuse, and it tells us that this side here is 15 centimeters long. All right, one of the legs is 10. It doesn't matter if I put this is 10 or this is 10, it doesn't matter. So I could call this B and this A, or this A and this B. But this has to be C. It has to be the longest number, the biggest number. All right, so anyway, let's plug this into our formula and solve for our missing leg. Well, one of our legs is missing, so we're going to leave that as A. We have the other leg. And we have the hypotenuse, which is 15. All right, so let's do what we can to this equation. We can't square A. We don't know what A is, but we can square 10. We know that's 100. And we can square 15, which I'm pretty sure is 225, but I'm just confirming that. Yep, 225. All right, so how do I find out what A is? Well, I want to get rid of plus 100. So I'm going to subtract 100 from both sides. So it tells me that A squared is 125. It doesn't tell me that A is 125. That wouldn't make sense. But the square root of A is 125. Well, the square root of 125 is 25, I'm pretty sure. I'm going to stick it in my calculator just to make sure. 125 is, no, I'm wrong. It's 5 square roots of 5. All right, so basically 125 would be 25 times 5. So basically 5 quarters would make $1.25. So if 125 is 25 times 5, 25 is a perfect square. Square root of 25 is 5 square roots of 5. Now remember earlier when I told you when we do the radical on the right side of the equal sign, we would automatically do the positive and negative. So normally that is true, but this is a real world, this is a word problem. And since a length can never be negative, that means our only answer is positive. So this leg is 5 square roots of 5 centimeters long. And if the directions said, round that to the nearest hundredths, I just stick that in my calculator and round it, because normally you wouldn't see centimeters with a radical, but it's still a real number. Okay. So remember, in real world problems, distance and speed and time can never be negative, so you always throw away that negative answer. All right, letter B says use the Pythagorean theorem to decide if a triangle with these measurements is a right triangle. So they give us the 3 measurements. So these two can be A and B, or A or B, either one, doesn't matter. However, this must be the longest length. So which one of these numbers has to be C? Well, it has to be 14. Now these, I could put 8 here or 14 here and vice versa. A and B aren't that particular. Whoops, should be a 12. But C must be the longest length. Okay, so these are A and B. So A squared plus B squared must equal C squared. So I'm going to let 8 be A, 12 be B, and 14 is C. So what is 8 squared? 8 squared is 64. 12 squared is 144. And 14 squared on my calculator is 196. Now, the way to know if this is truly a right triangle is if this statement is true. So 144, I'm plugging into my calculator, plus 64 is 208. Is 208 equal to 196? It is not. Therefore, this cannot be a right triangle. It's not a right triangle. It would be slightly tilted. It wouldn't be exactly a 90-degree angle over here in this corner. So since this does not go with the Pythagorean theorem, the answer would be no. All right, so here are some practice problems I probably got from Hawk's, the practice section. All right, so if you have a problem like these and the directions say use the square root method, so basically what you're going to do is want to solve for y or x, whatever your variable is. So since number 1, the y is already on one side by itself, to get that y squared to go away, we're going to find the square root of both sides. So we're going to find the square root of y squared, and we're going to find the plus and minus square root of 8. So the square root of y squared is y. 8 is 4 times 2, right? And isn't 4 a perfect square? So y is equal to positive 2, which is the square root of 4, 2 square roots of 2, and negative 2 square roots of 2. Positive 2 square roots of 2 and negative 2 square roots of 2. Like I said, in Hawks, you'll have to enter those answers separately. All right, number 2, I want y by itself. So since this is being multiplied by 2, first thing I'm going to do is divide both sides by 2. So now I have y squared is equal to half of 54, which is 27. My next step would be to get rid of the square by finding the square root of both sides. If I do that square root, I automatically want to do those two plus and minus. So y is equal to, so 27 would be 9 times 3. 9 is a perfect square, so my answers are the positive, or square root of 9 is 3 square roots of 3 and negative 3 square roots of 3. Number 3, we want x by itself. So we're going to get rid of that minus 50 by adding 50 to both sides. So we have x squared is equal to 50. Get rid of the x squared by finding the square root. We're going to put a plus and minus. So x is equal to, so this is going to be 25 times 2. 25 times 2, 25. Square root of 25 is 5 square roots of 2. And negative 5 square roots of 2. Those are our two answers. And number 4, we want to get rid of times 5. We're going to divide both sides by 5. So we'd have x squared is equal to 20. And then we find the square root of both sides. We're going to find the positive and negative square root of 20. So 20 is 4 times 5. 4 times 5, square root of 4 is 2. Left under the radical is a 5. And also negative 2 square roots of 5. Those are our two answers. All right, and then a couple more Pythagorean theorem problems. So I think this is the last. No, we have a few more. All right, so number 5, we're going to use the Pythagorean theorem to decide if a triangle with sides 6, 8, and 25 is a right triangle. So 6 and 8 are our legs. 25 is our hypotenuse. So we're going to do 6 squared plus 8 squared equals 25 squared, because a squared plus b squared equals c squared. So we have 36 plus 64. Well, I know that 36 and 64 is 100, and I know that 25 squared is not 100. I think it's 625. So 100 is 100 equal to 625? No, this is not a right angle. All right, let's look at these three numbers, where our two shorter sides would be 23 and 27. And the hypotenuse would have to be 34. So we're going to do a squared plus b squared equals c squared. So a could be 23, b could be 27, and c is going to be 34. So in my calculator, I don't know what these are, so we're going to use our calculator. 23 squared is 529. 27 squared is 729. And 34 squared is 1156. So I'm going to see, did these two numbers added together equal 1,156? 529 plus 729 equals, whoa, did I say the right number? Oh no. Did I say that right? Did I use 23? Yeah. So 23 squared is 529. 27 squared is 729, and 34 squared. So those two numbers equal 1258, does not equal 1156. So once again, the answer is no. All right, I think there's 3 more examples. Ooh, how can we read that? All right, so this says A is equal to 20. Good grief. 20. C is 25. And they want to know, what is B? B's a question mark. Well, since we know these are already labeled A, B, and C. So A squared is 20. B squared is, I don't know. And C is 25. So, come on. Why is it so fuzzy? So 20 squared is 400. Oh my word, what is wrong with this thing? It's tired. It's not going to clear up. Why? Ugh. All right, maybe it'll stay. All right, I know that 20 squared is 400. 25 squared is 625, I believe. Let me double check that. 25 squared. 25 squared is 6. Yeah. All right, so how do I get b squared? Well, I got to get rid of 400, so I'm going to subtract 400 from both sides. So b squared is equal to 225. So then how do I find b? Well, I have to find the square root of b. And the square root of 225 is 15. So b is 15. Okay? All right, on the next one, it says a is question mark, b is 9, and c is 15. So a squared plus 9 squared is equal to 15 squared. Well, 9 squared is 81. 15 squared is 225. We want to know what a is by subtracting 81. So a squared is equal to 225 minus 81. And we get 144. So what's the square root of 144? 12. And then letter 8b is 4 and 6, right? 4 and 6. This is 4, this is 6. So we have 4 squared plus 6 squared equals c squared. Well, 4 squared is 16. 6 squared is 36. Well, 36 plus 16 is what? 36 plus 16 is 52. 52 is equal to c squared. So the square root of 52. I'm just going to play on the calculator. It's 2 square roots of 13. So c is 2 square roots of 13. Whatever that is. 2 point something, 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 something. All right, so I've given you guys some practice problems and I have provided the answers to you. So I am going to, the only one that looks a little tricky to me, it might be, let's do number 4. I think y'all can handle the rest of them. They're not that difficult. So number 1, you're just finding the square root of 144, which is both 12 and negative 12. Here you're dividing 320 by 5, and then you find the positive and negative square root of that number. Number 3, I guess I'm doing all of them. All right, so number 3, you're going to find the square root of the positive and negative square root of 12. So then that would be 4 times 3. Whoops, that's a minus. 4 times 3, square root of 4 is 2 square roots of 3. So then what would we do? We would add 4. So the answers are positive 2 square roots of 3 plus 4 and negative 2 square roots of 3 plus 4. That's it. All right, and then finally number 4. We're going to find the square root of both sides. So we have 3x plus 1 is equal to the plus and minus square root of 54. So 54 is going to be 9 times 6. Well, the square root of 9 is 3. And then we want x by itself, so we're going to subtract 1. And then we're going to divide everything by 3. Now earlier I said if every single term isn't divisible by 3, we can't divide anything by 3. So 3 is divisible by 3, but 1 is not divisible by 3. So that means that nothing can get divided by 3. So the full answer is 3 square roots of 6 minus 1 divided by 3. That's the positive. And the other answer is negative 3 square roots of 6 minus 1 over 3. So since everything's not divisible by 3, that means we can't divide anything by 3. So hopefully that helps you guys. And they just use this sign to show you the answers, which is fine. But in Hawks, you have to type it separately because there isn't a button like this in Hawks. Okie dokie.